My name's Jose Rios. I'm in FMT 122 with Art, and we have a project that we have to propose and introduce into the class. So utilizing touch panel Allen Bradley T4T panel view and a Compact Logix L24ER processor. I went ahead and built an elevator. Now, built the elevator. The purpose of it is to show the capability of both the PLC and the panel view on exactly how you can program a piece of machinery or any kind of device to work a process or routine. And so I tried to show that in this project by working an elevator, just 2 levels up and down. And that's it. And I have some relays that control the forward and reverse, the forward and the slow speed, and then some just some rigging for moving the elevator up and down here, and then a proc switch to count the gears. And I need to calibrate it a little bit more, but it's close enough for right now. And so basically on the panel view I have the main screen, which is an e-stop that lets you go ahead and enable the circuit from the PLC. So it's an e-stop, and it tells you, it basically just is a quick stop for the motor in case you want to stop it. You can go ahead and stop the whole circuit from moving the motors. Your whole problem here, if you were working with a machine this big for people, the motor is very important, the gearbox, the sensors that monitor where the vehicle is. So you have a sensor for direction, and one for speed, and one for the high and one for the low. And they're in there, the back, I put a bracket on the back to find those. So right now it's all manual control for right now. So I'll go ahead and demonstrate it. All right, ready? So we're on the first floor, we're going to go to the second floor, so we're going to go up. All right, let's go. Okay. Made the switch in the back, so it's essentially stopped. So that's the second floor, so we have shoes, shirts, everything on men's work over here. All right, so go to the bottom floor. You press this button here, and just drop it all the way bottom. And that's pretty much how it works. So there is an intent with this. Why it was chosen? It was chosen because I took the second class, the 123. So I want to be want to use this to enhance it. Make it more like a real elevator. List of materials. Basically, your 24-volt relay is a spare just in case one peters out. Basically, some wiring here, a little gear down motor with a sprocket on it to count teeth, some bearings, and some angle iron. And this rigging is just a fish line and pulley from a closet door. And this is nice redwood finished wood. This box here, the vehicle, is a cigar box. That's it. So the electrical schematic, I have that. Show you a quick picture of it. It looks something like this. And there's some special thing with this print. It allows the forward and reverse power to be interlocked with one relay. So on two sets, it's a 4-pole relay. So 2 poles have power for forward, but if you energize the relay, it takes those power from those poles and brings them down to reverse, and then the reverse circuit is wired. So you can never cross the power when you reverse polarities. You have a relay to enable the forward, and then you have a relay to enable the slow and high speed, depending on which resistor you're using for the motor. Okay, short video we're recording now. And then challenges. Yeah, there were some challenges here. Getting the motor lined up perfectly with the proc switch and the rigging for the pulley. That was kind of tricky. Getting the circuit to be isolated electrically. Not only did I want it isolated and interlocked in logic, but you also do it in hardwire so that, you know, you'd have to have a double failure in order for this thing to run away. And that's the redundancy when you're moving people around in equipment. That's one of the things that you have to look at all the time is redundancy. Triple redundancy, sometimes quadruple redundancy, depending on how critical this system can be. So that is my project that I'm submitting. Any questions?
What's the weight capacity of the elevator?
You're not gonna be. It'll take your beer from here to there.
That's enough.
8 pounds.
Okay. So I don't know what it is. It's probably not more than 4 pounds, maybe 3 pounds. It'll pick up quite a bit of weight. It's all to save the line and all that kind of stuff, and keep it from breaking this part, the rigging. I used 8-pound test on the filament. Okay. Any other?
Was it hard to wire?
No, actually, once the wiring, I came up at, first of all, in my head what I wanted it to do. And then once I did that, then I started drawing it out so that I can kind of, you know, make sense. When a guy's looking at a print and he's seen a gazillion prints, he knows right away what to look for, which relays are the primary relays, secondary relays, interlocking relays. He'll know. So I try to draw it as consistently as possible, so that you can understand from the power, from the beginning of the power, all the way down to the output source, which is going to be the DC motor. Good question.
The coupler you have on your motor. Can you,
This part right
explain
here?
that a little bit more? Yeah.
Yeah, what happened was this motor had a shaft. So the center of a bolt got drilled out that matched the threads of this sprocket. So what I did was I added a bolt back here and then squeezed them together to get the pulley tight, and then I tightened the whole thing so it can butt up against the other bolt so it could all be one piece.
Very cool.
Okay, any other questions?
How about if the elevator when it go up to halfway?
If it goes halfway,
Uh-huh.
I do have a feature for that. It's manual mode. You can go to manual mode and then move it up and down in manual.
Okay.
Okay, and I'm not sure if it's working, but let's see how that goes. We got a little snafu here going on, but let's go.
I want to stand on the other side.
Yeah, he's coming back.
There is a manual feature, just it's not commissioned yet.
Okay, that's the one.
Yeah, it's for 123. Okay. Any other questions?
questions? Thank you very much. Very good.